Welcome to lesson number 8, Learn C Programming on the Raspberry Pi. In lesson 7, we started talking about pointers. Pointer is just another name for an address. And today I'm going to continue that with some more examples on how functions communicate with one another. So we'll start with a brand new program. And this time I'm going to write a short program that will compute the total amount of a bill that includes taxation. And we'll do it several different ways to show you how you can use functions in a C program. So first I'm going to make a prototype for my my tax program or tax function. So we'll start this way. Total. I'll just call it total for now, and it's going to take some different arguments. For example, it'll take float for the cost of the bill, float for the percent of the tax, and float for the total amount. So that's basically the cost plus the tax amount. Okay, let's now write the main. Float, cost, and tax, and amount. So here I'm declaring three variables. The cost of the item, for example, could be $10. The tax on that cost could be, let's say, 10%, and then the amount will be $10 plus 10%, which should come out to, I think, $11. So we will first we'll prompt a person to enter the cost and the tax. So printf enter cost of item. We'll just do it like this, and then I'll say scanf quote %f quote comma. Now remember, when we're using scanf, we have to give it the address of where we want to put this value. So I'll give it the address of cost. Then I'll say printf quote enter tax percent, and we'll do a scanf for that. Scanf quote %f comma, and once again, where do we put the tax? Well, we have to put the tax into the address specified by tax. So ampersand tax. Well, maybe what we should do is just do the computation first in the main, just to see how this will work. So we'll say amount is going to be equal to cost plus the tax percent. So let's say we put in 10% or 10 as our percentage. So then we have to say TAX divided by 100. So that'll be our taxes times the cost. Okay, and then we can print out printf quote your amount is %f / n quote comma amount, and return 0. So since we're doing it all in one program, I'm not writing this total function, so I'll just comment it out like this. Now we'll save this program. File, save as, well, this is lesson 8, so I'll make a directory here, create a folder called lesson-08. Oops, made a mistake there. Let me go back and make this one here, another one. Then I'll delete that one later. Lesson-08. Okay, and in lesson 8, our program is going to be, let's call it the bill, a restaurant bill or something like that, bill.c. Okay. Oops, I forgot to put a double quote here, and we'll save this. So a very simple program. We take the cost of the item. We also give it the tax on the item. We compute the amount, which is cost plus tax divided by 100 times the cost. And your total amount is this. So let's see if this thing will actually work. Save it, build it, and it says finished, compilation finished, build, and we will now execute it. Okay, so it's saying here the cost of the item, let's say $10, and the percent is 10%. Your total amount is $11. Okay, and we can run it down here. It might be more clear. Lessons. Actually, I can actually remove the lesson. Oops. Remove directory. So I'll just remove that bad one that I put in. So I can now just go to 08, and I can run bill again. Cost of the item, let's say $12, and 10%. Total cost is $13.20. Okay, so it seems to be working okay. But now what we're going to do is we're going to, instead of computing everything right in the main program, what I'd like to do is make a function that will do the computation for us. So instead of saying amount here, actually I'll say float. Return a float value. So instead of saying amount is equal to this, I'm going to say total, and I will put in here cost well, it's not really what I wanted to do. Let's go back. I told you I do things off the top of my head, so I do make mistakes. I'm going to do it like this. Compute the total cost tax amount. Okay. So the idea here is that we read from the user the cost, we read the tax, we call this function total to compute the amount, and then we print the amount. Okay, so void total, and I can say, I'll just say C, T, and A, float C, float T, float A. Okay. So remember that when total is called, then call by value suggests that cost will be copied to C. So cost is the actual parameter, C is the formal parameter. Okay, so once we have that, then I can say A is equal to C plus T slash 100 times C. And that's all we need for our function. So cost is going to be copied to C, tax will be copied to T, and amount will be copied to A. And then A will be computed as C plus T over 100 times C. Sounds perfectly logical, but it's not going to work correctly. So let's try it. Let's see, build, we will build it. Oops. Oh, here's a warning message. You notice it said compilation finished successfully, but we had a warning message. The warning message is on line 10, which says the amount is used uninitialized in this function. So in other words, what are we going to copy from amount to A? There is nothing to copy. So let's give amount an initial value equal 0.0. So we'll give amount an initial value. So now we have something here. This amount is 0. It can be now copied to A, and we shouldn't get that warning message. So let's save this. We'll go into build again, and this time we have no warning messages, and we can actually run it. I'll run it from here just so we can see it more clearly. So cost of item, let's say $10, 10%, and you see your amount is 0, which is incorrect. Now think about what's happening. When we run our program, we read in the cost from the user, we read in the tax from the user, and the amount is already set at 0. And then we activate this function. We do a call of total. So cost, the actual parameter, is copied to C. Tax, the actual parameter, is copied to T, the formal parameter. And the amount, A, the amount is copied to A. So A is 0. So this value here is 0 to start with, but it's computed here, okay? So A takes on a new value of $11. So right here, A is $11. In fact, we could put in here, printf, the value of A is %f/n quote comma A. Okay, so let's just rebuild this guy. No problems, and we will, well, I'll execute it down here again, and I'll say 10, and the tax is 10, and you notice the value of A is 11. So in the function total, A is 11. It's printed out here as 11, but it's never reflected back into main. In other words, when total finishes, there is nothing copied back. Remember, the way the parameter passing mechanism works is call by value, which means the copies are one way. Cost is copied to C, tax is copied to T, amount is copied to A. Nothing is really copied back to the main program. So that's why amount remains at 0. Well, how do we fix this? Well, we have to tell it that instead of copying the 0, we're going to copy the address of where the 0 is. And so when we call the function, we want to give it the address of amount. So now, well, we still have to put in here, that's star A, and then here we'll put the value of A, and here we'll put the value of A. So let's take a look at this now. What have we done? Well, in our prototype, the function total does not have any return value. The first parameter is a float, the second parameter is a float, but the third is a pointer to a float. In other words, the third is the address of a float, the address of a floating point number. Okay, so when we call the function total, what happens? Well, call by value says that this cost is copied to C. So C becomes 10. The tax is copied to T. So T becomes 10%. But the address of the amount, in other words, the address of where this variable is stored in RAM, the address is copied to this pointer we call A. So A does not equal 0 here. A actually is the address of where amount is stored. So now what we do is we say, well, the value of A, okay, and this one's saying into the address specified by A, put this answer in there. So we're computing the $11 total, and instead of putting it into A, we're putting it into the address that A points to, which is amount. Okay, so let's try this and see if it works. Build worked correctly, and we'll run it down here. $10, 10%, and you can now see the value of A is 11, so inside the function it's 11, and it actually copied the value. Well, it didn't copy the value back, it actually stored that value 11 into the variable amount. So it looks like things are copied back, but it's not really true. Okay. Well, there's another way we could do this as well. Instead of using the third parameter here, we could take it out and we could return its value. We could do it like this. I'll just code it up and then we can take a look at it. Now I'm going to declare A inside here. I don't have to, but I'll do it just to make it easier. Float A. Value of A is A, and then I'll say return A. Okay, let's save this guy. Now let's take a look. Here's our prototype. The name of our function is total. The first argument is a float and the second is a float. So we're just doing call by value twice to copy the cost and to copy the tax. So we're copying the cost to C, we're copying the tax to T. And then inside total, total has its own variable A here. Okay. And A is computed this way. We print out the value of A, but now we are returning A because we specified a return value here that's a float. Let's try it and see how it works. Build. Yes, and we'll run it down here. Cost of the item is $10 and 10%. And you see the value of A is 11. That's inside the function here. And your amount is 11. So look what's happening in this situation. In this situation, when we call the function total, the two copies take place to copy our data from actual parameters up here to formal parameters down here. Once the copy takes place, total is then executed. Total creates a float called A. It computes A with this formula, prints out the value of A in this printf statement, and then it returns A. What does that return do? Well, that return returns this float, this A, to this position in the main program. In other words, this function name is replaced by $11, the return value. So you can imagine that this what I've got highlighted here, you can imagine it's gone, and in its place I have 11. So 11 becomes amount, and it prints out 11. Not too complicated, is it? Well, it takes a lot of practice to get familiar with this. But remember that C program is made up of functions. Functions that are library functions or functions that are user functions. In any case, any program that's worth anything is going to have dozens or maybe hundreds of functions. And those functions have to communicate with each other. And I've shown you a couple of ways where data can be passed back and forth among these functions. Okay, let's just take a quick look again at, in fact, I'll close this window here, the Genie, and we'll just take a look here. I added in for the language terms, things that you should read about, compile, library, call by value, actual parameters, arguments, formal parameters or arguments, what is a function prototype, what is meant by a return value, and what is a pointer. And we could even put in address. An address. Pointer is just basically an address. And now you notice down here I said that asterisk is a pointer to, but it has other meaning as well. Well, one other meaning is basically multiplication. You can go, for example, 2 times 2 equals 4. But so in our last program we used the asterisk in 2 different contexts. We used it in multiplication to work out our total amount of our bill, and we also used it as a pointer, as an address. So you see there's 2 different meanings for the same symbol, for the same kind of operator. Okay, we'll save this guy, and I think we're done with lesson number 8. What you should do is, of course, practice. Run these examples yourself, change them, modify them, enhance them, make them a little bit better. Read about all the terms you've learned. Play with some of the Linux commands, and just get better and better. And we will see you later for lesson number 9.